Hello, and today we're going to be talking about Unit 2, Lesson 1, Reasoning, Arguments, and Proof, Part 1. Okay, our learning goals for today are to define and identify tools for informal reasoning such as observation, measurement, and experimentation, describe the properties of proofs, and draw conclusions based on formal or informal reasonings. Okay, we have two types of reasoning here. We have inductive reasoning and we have deductive reasoning. Okay, inductive reasoning. Inductive reasoning is a type of reasoning that is based on observations of patterns and past events. So experiences, so something that you've experienced, something that you've seen, or like a gut instinct. Okay, that is inductive. That's what you find inside. Okay. Deductive reasoning, okay, is a type of reasoning that uses previously proven or accepted properties to reach conclusions. So like definitions, postulates and theorems, proofs, okay? That's deductive reasoning, okay? Mathematical proofs is a clear and logical structure of reasoning that begins from accepted ideas and proceeds through basic logic to reach a conclusion. Okay, this is like the valid way to draw conclusions in mathematics. And so we kind of have like this representation right here. We have a valid premises plus some sound logic will give us a proven result. So this unit, all of Unit 2, is kind of a whole different way of thinking about mathematics. We're not necessarily trying to like do mathematical expressions like 2 plus 2 is 4. Okay, we're trying to say why can we do something. So like if you look at this given problem, so I'm given that 3x minus 9 equals 0. I need to prove that x equals 3. Okay, so we're going to start with the given statement. So I've got statement 1 right here. That's the given statement. The reason why I can state it is because it's given. So you see how proofs are, like we're not wanting to find the answer for it. We're trying to find the reasons why we can do it. Okay, and then step 2, we got 3x equals 9. Well, what we did here is we subtracted this 9, or we added this 9, its inverse operations, to both sides. So we have to state the reason we can do that is from the addition postulate. Then we get down to the last step, x equals 3. So what did we do? Well, we divided both sides by 3. So our reason that we can state that is the division postulate. Okay, so working through proofs, what we're doing is we're just trying to find the way to do something, not necessarily the answer itself. Okay, so here's an example. This is an example of like what a proof might be. We've got a given, so we've got these two triangles that have all their tick marks and are labeled for us real nice. And then we have all these statements. So this is an example of what a proof would look like. Okay, we can state this whole first thing to begin with. Okay, so that needs to be our first statement, and the reason we can state it is because it's given. So a premises is given information that can be assumed to be true, okay, because we're given that material. Okay, then to get to the next point, well, we have to look at some of the information that we're given. So like that AM is congruent to MD, that BM is congruent to MC. Well, that's the definition of a midpoint, okay? And so there we're using deductive reasoning and we're saying, look, okay, I've got this definition that I can state right here. Okay, then the next statement about angle AMD and DMC. Well, those are vertical angles, so that's why we can state this. And we're going to teach you how to write proofs, but right now I'm just trying to show you an example of proof. So again, that's using deductive reasoning. Here's another, we can talk about these two triangles being congruent. We can use it by side angle side theorem. That's also using deductive reasoning. Whoops, there it is. Okay, and then the last one, we're also going to use another definition. Congruent parts of congruent triangles are congruent. Okay, and then we can get to the last. It's the converse of that. It's a valid conclusion, and that's how we can come up with that statement. Okay, so if you look at this, things that we could use in a proof, we can give given information. So we can give the stuff that's given to us. It's also called a premises. We can use deductive reasoning. So we can use definitions. We can use theorems that have been proven. We can use proofs that have been proven. And valid conclusions. Those are all parts of a proof. Okay, so this is a geometry proof. Okay, we're given the true premise. We're given this diameter, or we're given this circle and some information on it. And then it's going to write it out, and it's going to kind of do it in paragraph form. So in every circle, the radius is half the diameter. Therefore, the radius in this circle must be half the diameter. 1/2 of 10 is 5. Okay, so it just kind of writes it out. And then we have another valid conclusion. So we've got true premises, deductive reasoning, valid conclusion that makes up that proof. Here's another algebraic proof. Okay, we're given this equation. Okay, and we know that we have to get to an answer. And so we're going to start with the equation, and we can state it because it's a true premise. Then we go through all of this deductive reasoning, and we're just doing the steps to get there. Then we reach a valid conclusion that x equals -3. So again, we're just talking about the parts of our proof, and then later on in a video we will show you how to actually write a proof. Okay, so looking at some examples, and if you see, you are exempt from Lesson 2.01 quiz, but you still need to get this content, so I'm going to go through this quiz with you. It says, which of the following is not a property of mathematical proofs? Well, let's look at true premises. True premise, we have to have one of those to start a proof, okay? So we have to have that. Inductive reasoning. Remember, inductive reasoning is kind of like our instincts, our gut feeling. Okay, a conclusion. Got to have a conclusion. Deductive reasoning. That's all the rules and the definitions we can use. So the one that is not is inductive reasoning. Next one. Examples of tools used for inductive reasoning include each of the following except for what? So remember, inductive is using like our gut instinct, using patterns, using observations, using all of that stuff. So experimentation, yes. Patterns, yes. Observation, yes. What you don't use in deductive reasoning or inductive reasoning is deductive reasoning. Okay, you can't use one in the other. Here's another example. It says, in step 1 of this proof, which of the following is which of the following? Okay, so I'm going to just look at step 1. That's the given piece of information. The given piece of information we call the true premise. Number 4, step 5 of the proof demonstrates what? So let's look at step 5. I'll highlight it. Okay, it's the end of the proof. We're done with the proof. This has finished it out. And so what do we call that? We call that a conclusion. And lastly, if you use deductive reasoning, what is the conclusion to the following? A parallelogram with 4 congruent sides is called a rhombus. A square is a parallelogram with 4 congruent sides and 4 right angles. What is the conclusion? The conclusion would be that a square can also be called a rhombus. Okay? A rhombus can't be a square because it doesn't have 90-degree angles. A rhombus does not have the right angles, so it can't be there. And a parallelogram is either a rhombus or a square. Well, that's not too exact. So our answer is a square is a rhombus. All right, guys, this wraps up 2.01. Then you may finish with 2.02, and that will conclude your Monday. Thank you.